Graphs are descriptive and presentational graphics that are used to summarize and display data for researchers to explore their own data, and is the best way for a target audience to interpret that data. In first year biology subjects at the University of Adelaide, you will be generating graphs to investigate correlations between two variables, how one variable affects the other. You will then use these graphs to interpolate or estimate a value based on the known values from these graphs. Examples include investigating the correlation between concentration of SLS in waterways and its effect on death of marine organisms, the correlation between sucrose concentrations and plasmolysis in plant cells, the correlation between light intensity and rates of photosynthesis, and, if you are doing MGC, identifying unknown DNA samples based on known DNA base pair sizes. The simplest way to display a correlation or relationship between two variables is to create a scatter plot. Using these data points, one can generate lines of best fit, or trend lines, that explain the trend. There are many kinds of trends. A trend can be increasing or decreasing. It can be linear, or exponential, or logarithmic, or sigmoidal, or polynomial, just to name a few. Of course, it can show if there's no trend at all, that is, there's no correlation between the variables. The graphing package that you will be using is Prism. Prism is available to all University of Adelaide students. In this tutorial, I will show you how to use Prism. Note that you will be expected to know how to use Prism before attending the practicals. The explanation of how to use Prism is not part of the practical itself. However, this tutorial will be available to you to use as part of your pre-practical preparation, as well as during the practical itself. Demonstrators are available to help you if you are having difficulties, but due to the large number of students in the class, the demonstrators will not have time to give one-on-one tuition to students who do not have the basic understanding of how to use Prism. So here how Prism operates. When you first open Prism, a welcome dialog appears, which asks you to choose an appropriate type of table for your data. You can see to the left of the screen that there are 6 different types of tables in Prism to choose from. For all of the graphs that you will be generating in molecules, genes and cells, and for concepts in biology, the only type that you will be using is an XY table and graph. The XY tables and graphs are the default for Prism. An XY graph is ideal for plotting the relationship between two variables. The little image at the top of the window shows you how that graph might look. On the right hand side here, Prism needs you to choose options in regards to the graph itself. One is related to the x-axis and one to the y-axis. For all of the graphs that you will be creating, select numbers for the x-axis and enter and plot a single y value for each point for the y-axis. The other choices here would be used in situations where you had entered replicate data or wanted to show error values. You will not be doing this. Any replicated data gathered during your practicals will be collated for you by the demonstrators. But if you would like more information regarding the use of the other selections, informative tutorials can be found at the above website. So here we have selected number for the x-axis and enter and plot a single y value for the y-axis. So now we hit create. An empty data table will appear that is ready for you to populate. Here on the left, this table shows up as data 1 and the corresponding graph shown here as also data 1. If I click on it, you will see that there is a graph ready to be created. Here in the table, the first column is titled X, as it will be populated by the values of the x-axis. but there are multiple columns titled Y, which represent the number of lines that your graph will show. For most of your graphs, you will only be using column group A, representing one line on your graph. However, for photosynthesis practical, there will be 2 lines on the graph, so in that situation you will populate 2 columns of data, group A and group B. Now to enter some data. I will copy and paste this straight from an Excel worksheet. It is just some made up data that I have used. Concentration increase of something over an 8-hour period. We'll copy and paste. You can see that the axes titles have automatically populated themselves. Here is the title of the x-axis, time in hours, and here is the y-axis title, concentration in mils. Now click on Graph Data 1. The pop-up graph gives us a few different choices on how you want your graph to look. In all of the cases for graphing this semester, you'll be creating a scatter plot and inserting a line of best fit or trend line. The line of best fit is not always linear. In fact, in most of the experiments that you will be doing, the correlation between the 2 variables will not be linear. And in no cases will you be creating a join the dots type graph, so be warned. So scatter plot is what you want, so click OK. To add the trend line, go up to Analyze, then select Non-Linear Regression, then select Standard Curve to interpolate. Here you will find most of the choices that you will use, but you can look around at others if you want to. As you can see, there are also more exponential and polynomial choices. You can now experiment and look for the line that best fits the trend of your data. Line is here if you want to see if there is a linear trend. To have a look at other choices, click on this little red grid up the top. The most frequently used graphs in MGC and CIB are sigmoidal, second or third order polynomials, and occasionally exponential, but you can play around and see which you think is the best data. Let's look at sigmoidal. That's better. What else is there? Let's try a third order polynomial. Not as good as the last one, I think. Let's have a look at, say, exponential. A 2-phase. No, I don't like that one. I think I'll go with sigmoidal. Now to format the graph itself. You may want to change the title of your axes. The easiest way to do that is by clicking on the axes titles themselves. A text box will appear for you to add your titles. Let's change units here to minutes. And of course, milliliter is not a unit of concentration, but of volume. So I'll change this to volume. You can also change the length of the axes by clicking on the end of the line and dragging it left or right, or up or down. You may want to do this to get more resolution in your trend line. To change the axes themselves, double click on the axes and a dialog box pops up. Here you can change anything about the axes themselves. This is also the place to find how to change the scale of the axes. If you are doing MGC, the graph that you will be generating in Practical 5 requires that one axis uses the log 10 scale. So here is the y-axis. The default is linear, but by selecting log 10 and clicking OK, you can see that the y-axis scale is now in log 10. But this is not relevant here, so I'll change it back. So this looks to be the best trend line to fit the data, but the question in the practicals usually asks you to use this trend line to interpolate something that was not actually measured. For example, you may have been asked how long it takes for volume to reach 0.5 mils. Up here is a draw tool. I've chosen to select an elbow, and I will start drawing from the 0.5 mils and click when I get to the trend line, then draw down to the x-axis and click to finish. Well, I'm really not sure what that time is. I can have a guess, but the question wants me to be more precise. So what I require are more ticks. I will double click on the x-axis and the Format Axis dialog box appears. I deselect Automatically Determine the Range and Interval box. Then I will select Major Ticks and change this to 1 and Minor Ticks to 4. This will give me a time interval to the nearest quarter of a minute. Click Apply and OK, and I have my answer. I can see that it takes approximately 3 1/4 minutes to reach 0.5 mils. You will note that there is a place here to add a graph title. Titles are not placed above the graph itself in written work like papers and practicals. The titles of the graph become part of the figure legend. They are only used for posters and projects and projected images where people may have a harder time reading small print. A larger font is very helpful, so don't add titles onto the graph itself. This is deleted. You can make changes to the graph just by changing the table. You will notice that for this graph the trend line doesn't start at 0, 0. We can adjust that easily. Click on the table and add 0, 0 to the bottom of the column. And you can see that this has automatically changed the graph. This graph is now ready to copy and paste into my worksheet. It has axes titles with units, a clear trend line, and interpolation lines. There are other ways to make these changes, and if you're comfortable with doing it another way, please feel free. These are just recommendations.